Hello and welcome. In today's video, we are going to be evaluating limit by the help of L'Hopital rule. So when is it necessary to use the L'Hopital rule to evaluate limits? So let's assume if we have two functions f of x and g of x. The only time we can use the L'Hopital rule to evaluate a limit is that if f of x, if the limit of f of x as x approaches certain value, we call that a, is equal to the limit of g of x as x approaches that value, right? And the equation of those two limit, the limit as x approaches a of f of x over g of x, if these two limits are the same, imagine this is 0 and this is 0 here, is going to be equal to the limit as x approaches that value a of f prime of x, which is the derivative of x, over g prime of x, which is the derivative of g, right? So this is telling us that if we have a limit, two equal limit, the derivative of those two limits will be equal to the limit of that function. So for example, let's say for instance, if we have the limit as x approaches infinity, by substituting infinitive into this equation, we end up getting infinitive over infinitive. So in this case, we can use the L'Hopital rule to evaluate this limit, right? So what if we have the limit as x approaches 0, right, of s cubed over s squared? In this case, by substituting 0, we'll end up getting 0 over 0 as well. So we can also use the L'Hopital rule to evaluate this limit, right? So the L'Hopital rule, or some call it L'Hospital, can be used to evaluate this limit. So the next thing that I would like for you to know before we can start evaluating limit is some basis derivations rule. Let's say for instance, if you have of x raised to the power of n, in this case, by differentiating x raised to the power of n, we use the power rule, which is x raised to the power of n minus 1 times n. So in this case, we'll have n x raised to the power of n minus 1. So for example, if you have x raised to the power of 2, this is going to be 2 times x raised to the power of 2 minus 1, which is equal to 2x, right? If we have sine x, the derivative of sine x is going to be cosine x. And if we have a function, let's say d over dx of sine of 2x, in this case we have to use the chain rule, which is right, you have to differentiate the outside portion here with the sine and maintain the inner portion and multiply that by the derivative of the inner portion. So what I'm asking, let's say for instance, if you have this and you want to differentiate it, the outside portion here is sine and the derivative of sine is cosine. So we have cosine. We have to maintain the inner portion, which is 2x, right, time the derivative of the inner portion. Now let's say, for instance, if we have the limit as x approaches 0 of 1 plus x minus 1 over x. The first thing we have to do is to substitute the value of x, which is 0, into the expression. If it turns out to be 0 over 0 or infinitive over infinitive, right, we can use the L'Hopital rule to evaluate the expression, right? So let's try that. We can see the limit as x approaches 0 of 1 plus 0 minus 1 over 0, right? So this limit is going to be 1 minus 1 over 0, which is 0 over 0, right? Since it is 0 over 0, then we know that we can use the L'Hopital rule to evaluate this limit, right? So we can see the limit as x approaches 0, right, of square root of 1 plus x minus 1 over x. We are going to differentiate the numerator and the denominator separately, right? So note that we cannot use the equation rule of differentiation whenever you want to use the L'Hopital rule to evaluate limit. So this can also be written as the limit as x approaches 0 of 1 over 2 minus 1 x prime, right? So by looking at this problem, we know that this is a function, and if we have a function, let's say f of g of x, this is going to be differentiated as f prime of g of x, leaving g of x the same, time the derivative of g of x, which is g x prime, right? So in this case, we can say the limit as x approaches 0. So by differentiating this function, we are going to differentiate the function f, which is going to be 1 over 2, right? 1 plus x, 1 over 2 minus 1 here from the exponent, times the derivative of the inner portion here, which is 1 times 1, all right? And the derivative of a constant is 0, so we don't need that. And also the derivative of x is 1 or 1. So in this case, we're going to have the limit as x approaches 0 of 1 over 2, 1 over 2, 1 plus x. And if you subtract negative 2 from 1, we're going to end up getting negative 1 over 2. So This can also be written as the limit as x approaches 0 of 1 over 2 root 1 plus x. So in this case, substituting 0, we'll have 1 over 2 times 1 plus 0, giving us 1 over 2 as our final answer. So let's say if we have a limit, x approaches 0 of sine 4x or over 5x. So we are going to differentiate the top and the bottom too as well. You can see the limit as x approaches 0 of sine 4x over 5x, right? So you can see the limit as x approaches 0. We also know this is a function too as well. You can say sine x or sine 4x can be written as cosine, because that is the derivative of sine, cosine of 4x, leaving the inner function the same, times the derivative of the inner function, which is 4, or over the derivative of 5x, which is 5. Right? So we can try to substitute the value of x in this case. We'll have cos 4 times 0 times 4 or 5. Right? So cos 0, but this is going to be 0. Cos 0 is 1. So 1 times 4 is 4. So we'll have the limit as x approaches 0 of cosine of 0 times 4 or 5, which is 1 times 4 over 5 equal to 4 or 5. So that is the limit for that. And let's get another example. Let's say if we have a limit, as x approaches 0 of 1 minus cos 2x over 1 minus cos 3x. So how can we evaluate this limit? Right, the first thing we do, let us try to substitute. So by substituting, we will have 1 minus cos 2 times 0 over 1 minus cos 2 times 0, right? And cos 0 degree is 1, and 1 minus 1 is 0 over 0. So we can use the L'Hopital rule to evaluate this limit. So we have the limit as x approaches 0. If we differentiate a constant, we're going to have 0. Then if we differentiate cosine, we'll have negative sign, leaving the inner function alone. And multiplying that by the derivative of the inner function, which is 2. Then the same thing is going to be in the bottom as well. But this time around, we're going to multiply by 3 because the derivative of 3x is 3. Alright. So the limit as x approaches 0 of this and this is going to be positive, and this is also going to be positive, of sine 2x times 2 over sine 3x times 3, right? So let's substitute 0 again to evaluate this expression. By substituting 0, we're going to end up getting sine 2 times 0 times 2 over sine 3 times 0 times 3. So this is going to be sine of 0 is 0. So we're going to have 0 over 0 here. Alright. So we are still going to use the L'Hopital rule to evaluate this expression. So the limit now, let's say the limit as x approaches 0 of sine 2x times 2 or sine 3x times 3. We are going to differentiate both the top and the bottom again. So in that case, we will end up getting the limit as x approaches 0. So the derivative of sine is cosine. So we have cosine, leaving the inner function alone, 2x, times the derivative of this inner function, which is 2, times our original 2 here. So the same is going to be applied here. We have cosine of 3x times 3 times the 3 that we already have here. So we have the limit as x approaches 0, right? X approaches 0, right? Let's substitute the value for 0. Now, so let's substitute the value of x. We'll end up getting the cos 2 times 0 times 4 over cos 3 times 0 times 9, right? So cos of 0, because this is going to be 0 and this is going to be 0 too as well, and cos 0 is 1, so we end up getting 4 over 9 as our final answer. Alright, so that's it for this video. Thanks for watching.